This one, let's take a look at the following. Determine an equation for the graph of a polynomial. Write your answer as a product of factors and assume the leading coefficient is 1. The part that says the leading coefficient is 1, just assume that for our purposes, that means that the number in front of the polynomial is just 1 and the highest term. Don't concern yourself too much with that. What is important though is this. Take a look. You see where the graph crosses the value -2 right here? That -2, that's a root. So x equals -2 is a root. You get a root from solving by setting a factor equal to 0. So in other words, normally we set factors equal to 0 and get roots, but now we're going backwards. We're beginning with a root of -2, and by moving that negative to the left side so that it becomes +2 this way, this quantity right here, that becomes a factor of our polynomial. So it's the variable, whatever it happens to be, together with the number. So the x plus 2 is a factor of our polynomial. So this is one factor, x plus 2, beginning with -2 as the root. So notice that the factor and the root have opposite signs. The root is negative and the factor becomes +2. Let's do another couple of these. So like this one, you should pause the video and try it on your own, but I'll do it. So here, for example, you see that originally the root is +1, right here. This is +1. So that now to get a factor from this, what you do is you subtract the 1, you move it to the left with subtraction, so it becomes x minus 1 equals 0. And now this quantity, this is another factor of the polynomial. The polynomial is the curve that you see. X minus 1 is a factor of that polynomial. And the same thing applies over here. So the root over here, the root is x equals 2, positive. But when you subtract like that, you end up with x minus 2 equals 0. That x minus 2 then becomes the last factor of the polynomial. So here, you're beginning with roots and you're going to factors instead. And notice that for all of these cases, when the root is positive, the factor has an opposite sign. And look, this is the graph that you see, that curve. So now what you can do is, using the factors, you can rebuild the equation of the polynomial. You can type y equals, and you multiply the factors together. So x plus 2, and then you multiply x minus 1, and then after that you multiply x minus 2. If you wanted to, you could multiply all of these out, and then you would see that would give you, for example, a cubic polynomial. Okay? So that's one fact. Now, let's go on to another problem. We're going to make use of this. Take a look. It says, factor the following expression completely given that one of the roots is -1. So first, you're told that one of the roots is -1. You keep the root in exactly the form given when you do synthetic division. And you want to do synthetic division because that will allow you then to factor the polynomial. The polynomial is w cubed plus 5w squared plus 7w plus 3. You want to factor it. I already have the answer pre-written here, but I want to show you how to get the answer. So I'm going to do synthetic division. Take a look. I'm going to write my root right here. So this is my root. I write the coefficients from here, so it becomes 1, 5, 7, and then 3. You don't have to stuff in any zeros here because it's already arranged from highest to lowest. Take a look. This is already w to the third, w to the second. This is like w to the first. So they already go 3, 2, 1. You're not missing any powers of the variable. So you can just put the 1 from here. That's the first one, then the 5, the 7, and the 3. You're using those. Okay, let me erase that straight mark here. So now at the next stage, you do synthetic division. You bring the 1 down. 1 times -1 is -1. You add straight down. 5 times -1 is 4. 4 times -1 is -4. You add straight down. 7 minus 4 is 3. 3 times -1 is -3, and then you add straight down. So that gives you a remainder of 0. So here, because the remainder is 0, this tells you something important, that the following is true. In other words, this value of -1, as you can see, is a root. And I know that because the remainder is 0. So when the remainder is 0, and you put a quantity right here, that tells you that the quantity is a root, in other words. It also means the following. Please look carefully now. It says that this is one of the roots, -1. How do we get roots? You take roots, go back to the previous picture, right? Roots are these things right here. Like this is a root. To get a factor out of it, you write the variable equal to the value of the root, and you move the root to the other side with the appropriate operation to get a factor out of it. Same thing applies here. Look, the variable is w, so up here I'm going to say w equals -1. That's a root of the polynomial. That means if I plug -1 into every term, it will make the value of it equal to 0. So to make a factor out of this, I add 1. On the left side, you end up with w plus 1. And on the right side, you end up with 0. These cancel. So this tells you that w plus 1 is the first factor of the polynomial. And you see that in the list that says show answer. So here I'm going to put the following, w plus 1. That's the first factor of our polynomial. But now go back to the synthetic division. You see where it says 1, 4, and 3. Remember, when you do synthetic division, or any polynomial division, this represents the term that is 1 degree lower than the one you started with. So because you're starting with w cubed up here on the left side, down below, this 1 and the 4 and the 3, those are the coefficients of the quotient. So you're going to write the follows. You're going to write w squared. If you want, you can put the 1 in front of the w squared. It makes no difference. That represents the coefficient on w, and the 3 by itself is the constant. And now we want to finish the factorization. To achieve this, we take our w squared plus 4w plus 3, and we factor that again. So look carefully. I'm going to say over here, let's do the factorization. So I need two numbers that multiply together to give me 3 positive, and the same two numbers added together have to give me 4 positive over here. Let me erase that, and that also. So now think of these two numbers, not too hard. 3 and 1. So 3 times 1 is 3. 3 plus 1 is 4. So now over here I'm going to put w plus 1, and I'm going to put here w plus 3. So these are the other two factors of our polynomial. The w plus 1 is another factor, the w plus 3 is another factor. So I put that in a box right here, where it says w plus 1 already. I add w plus 3, and then I add w plus 1 again. So let me zoom out so we can see the whole process. So begin with the root as a review. Perform synthetic division. On the bottom you get the quotient, factor that. Take the factors from the bottom step, combine them with the factor that you get from the root, and the 3 factors then you go in the box. Thanks so much.